Okay. Hello. So I have no idea how far I'm going to get in this recording, so I may rapidly change clothes. Or lighting, or sound. Who knows? It is a mystery to all of us. So I have a meeting in 2 minutes. So let us see. Alright. So we're going to do a little bit of hands-on data wrangling today. And we're going to be working with just a single data frame for now. It's going to get fancier, but let's just start here. So you have a single data frame. Cool. Now what do you want to do with it? Do you want to slice it, dice it, juice it, process it? I know, it's lame. I'm lame. But let's actually work on it. So you remember that hotel data set that we worked on like a gazillion years ago? Well, let's work with it. So here I'm using the select function, and we are just selecting lead time. That's it. I lied. Selecting lead time and hotel. And we are piping hotels into that. All right. Now we can also do this cool thing called select with a minus. So we can select everything except the variable we've highlighted if we put a minus in front of it. So here we've selected everything but agent. Because this data frame originally, this tibble originally had 32 in it, but now it only has 31. Okay, we can also select a range of variables within our data frame. So we can select everything from hotel to arrival by date and month, and it will select every variable in between those in our tibble. Now, I do caution against this because it depends on the pre-existing structure and ordering of variables, which you can rearrange. So this is doable, but just be mindful. It runs the risk of being a bit of a pain later. Okay, other things we can do include selecting a variable with certain characteristics, including starts with. So we can select every variable that starts with the string arrival. And this is useful if you're working with repeated measures or you're really doing anything with a pre-existing rational naming process. It can be helpful, for sure. And this creates a table with only 4 variables in it. You could also do it ends with type. And so there it looks at the names of all your variables and only selects those that end in type, which is pretty convenient. So there are lots and lots of helpers in the select function. I tend to have to look these up because there are so many. If you need help with these specific functions, you can kind of get more info with a question mark everything, and it will summon lots of information for you. We can read through these if you would like. Oh, you would like? Wonderful. So, starts with just whatever the prefix is. Ends with the suffix. You can select anything that meets those criteria. Contains anything in there, a literal string. So it could be in the middle, it could be at the end, it could be at the beginning. Contains is useful if it ranges where it's from, but the more specific you can be, the better. You can also do a number range, so it matches a numerical range like 1, 2, 3, 4. One of, so it matches variable names within a vector, so you can have it look for multiple things. You can have it match all the variables, or select the last column. You can also offset this, so second to last, third to last, etc. As well as matching. Matching gets into regular expression, which is super helpful, but is a little daunting at first. For me, I only finally got a handle around regular expression by working on this fun little Wikipedia project that's essentially a giant autocorrect auto wiki browser, pretty much. And so I learned it by doing. You eventually get better at it, but it captures a lot of other aspects here. Okay, what about sorting? I know we did this a little earlier, way back. But I want to show you that you can do like multiple pieces here. So we can pipe. Sorry, that it is very important to not miss that pipe. So for hotels, we can select adults. Let's actually make this a little smaller. Nope, I do not have time. So in theory, I could make this smaller so you could see that it's piping. And remember, pipes go from top to bottom. So hotels get selected into select in the first spot. And then whatever your outcome is of select gets popped into the next one. And so here in our third row pipe, we've sorted by babies. And the default is ascending. And if you want to rearrange it by descending, you've got to use disk. Fun facts. All right. So we can also slice by just a number of rows, oftentimes just to get a little peek at the data. Maybe you'll look at the first 5, and so you can slice by 1 through 5. This will generate a vector of 1, 2, 3, 4, 5. You can use slice to just get a peek. So just a fun fact and tip. So in R, you can use the hashtag or £, depending on how old you are and how much Twitter you've experienced, for adding comments to your code. So any text followed by a hashtag will be printed as is, and it won't run as R code. So it's useful for leaving comments in your code, as well as for temporarily disabling parts of your code for debugging. Super helpful, because future you will have amnesia and have no idea what you did. Well, they'll see what you did, but they won't know why. So use the code to write notes to future you, because future you will thank you. So here, as we can kind of, I might zoom in, but this hashtag here, slice the first 5 rows. This line is a comment. Also select, this one doesn't run. And so in this data set, only the last one runs, and the pipe will just kind of keep looking for the next line that's not commented. So while this line runs, this comment doesn't. It's pretty useful. All right, so you can also slice for a certain number of rows. So you could slice for the last 5. So you can figure out, so instead of figuring out directly and just knowing that your data frame has like a gazillion rows, instead you can get the length of rows. So essentially the number of rows it gives you in row. Make that as its own little variable just for your own sanity. And then you can slice by last number minus 4 to last number, and that'll give you 5. So there's some kind of clever ways to like get this to do what you want. And it's those clever things that vary a lot. So anyone who's had pre-existing exposure to R in this class has probably seen lots of clever things that I have not been aware of. It is possible. I am not all-knowing. But my point is that you can slice and dice, and there are clever ways to do it. And if you find a clever way, use it. Just if you have a source for that clever way, cite them, at least in your code, so you can remind future you where you got it. All right. We can also filter, where we are just doing a subset of rows that meet a certain criteria. Here, hotel has to equal exactly city hotel. The double equal is exact equals. And so it will give us a tibble with almost 80,000 options instead of the like gazillion, because it's only including the hotel that equals exactly city hotel. If we had some that said just city, it would not include those because it has to match it exactly. So we can also filter for multiple conditions at once, which is kind of helpful. So we can filter when adults are 0 and children is more than 1, or greater is 1 or more. So we can see here we've got cases where there are 223 in our data set with children staying in hotel rooms by themselves. I mean, there could be babies, that's not restricted here, but my point is that you can filter with multiple pieces. All right, so you can filter with even more complex pieces. So in addition to, so here we've got adults equal 0, and filtering by children is greater than or equal to 1, or that's what this bar is, babies is greater than or equal to 1. Just for the, okay, so there are no babies that stay home alone. That will stay alone in a hotel by themselves. That's a good thing. In all likelihood, if you saw that here, either we'd have a bigger issue or there's some data input issue. Okay, logical operators in R. I'm going to just leave this here. So we've got less than or equal to, greater than or equal to, exactly equal to, not equal to. This one's my favorite. Or is the bar isn't it? This is useful. It's not, so it's a way to determine if you have missing data or not. So here it would only include stuff that is missing, and is not NA would only include those with it. You can also look in subsets to see if X exists in Y or if X does not exist in Y. Lots of nots with the exclamation point. All right, so it's your turn. So go and you can start working on exercise activity 4 and make your way to exercises 1 through 4. Cool. You can pause here, unless the video looks like it's about to end, then you can just let it run. It's really going to depend. Oh, I've designed it to be a pause. For you. For me, we're going to cut. So I can go to my meeting. Bye. Hey there. So we are back. Well, I'm back. You just got to see a weird transition. All right. So we were paused while you worked on activities 1 through 4. So let's continue. So we can use distinct to filter for unique rows and arrange them alphabetically. So we can do lots of stuff. Piping gives us some really nice tools. So we can filter. We can filter by market segment or unique market segment to just see what they are. And then arrange it alphabetically for our own sanity. Okay, I'm going to show you what my current setup is so you can see the nonsense. Yeah, this is my tripod. It's very it's a lost cause, kind of, right now, clearly. Okay, let's see if we can raise this. Nope, we cannot. Awesome. Let's move it a little closer. There. Great. Awesome. Okay, let's keep going. So we can identify unique rows so we can get a sense of what's in there. And then arrange them. We can also see if there are distinct combinations. So if we do distinct by hotel and market segment, it'll find every combination that's unique. So as you'll notice here, we have city hotel complementary as well as resort complementary to kind of show you the two pieces. And here we've arranged them alphabetically. Guess who has the mouse? Hi, Archie. Can I help you? Apparently I cannot. Hi. Okay. Ooh. There we go. So, yeah. So we can also look at doing frequency tables. To count kind of gives us that nice summary where it tells us how many columns or how many rows there are for each segment. And we can see that there are only 2 for undefined, but that most of them are group bookings or offline tatos. Do I know what a tato is? Nope. But I bet you could figure it out by crawling through the data. So we can also sort those counts by, and it will sort them from most to least. Because alphabetical, not always super helpful. We can do other cool combos. Ascend in frequency order, so we can count them and then arrange by the sample. So here we can do it from ascending. But if we want to do it by descending, we can either do it by sort or true, or we can pipe that all into a range. There are multiple ways to do it. Okay, now we can also count multiple variables, again, to see what the combos are. So we know that City Hotel had 2 undefined, and Resort Hotel had none undefined. Can be pretty useful. All right, so the ordering matters when you use count. So if you order by a City Hotel and then by aviation, it will, well, do it that way, as we can see here. And so it will rearrange your data based on how you ask it to look at it. So your turn. Open that markdown file and make your way through exercises 5 and 6. Cool. Feel free to pause, because I'm not going to dance for the whole time. I may throw in some ukulele music for my own joy, but yeah. Cool. So let's try some new stuff, like mutate. So mutate creates a new variable, where here we want to, so we're creating a new variable called little ones. And it is just the summary of children plus babies. So you just add up those 2 columns. You could divide them if you wanted, but I mean, I don't really know why you do that, but it's possible. All right, so we've piped hotels into mutate. Now we've made this data frame with a new variable in addition to that. So it's hotels plus little ones. And we're going to pipe all that into select so that we're only going to grab the 3 variables we're interested in: children, babies, and little ones. And then we'll arrange it by the total number of little ones. And as you can see here, we got a room with 10 kiddos. That's a room with 10 little ones. We got a room with 10 babies, also 10 little ones. But you can add them up. I have no idea why there are 10 babies in a room. But you can figure out and crawl deeply in to see what the deal is with that. Because that's a lot of babies. So now that we've got to keep throwing it. So if you want to keep that variable in there, you either have to mutate it and then assign that to hotels. Because right now this isn't saving any of those changes. It's just spitting it all out for you. Here, hotels. We're mutating to create those weird little children, and then we're filtering it based on more than 0 little ones and it being the resort hotel. So then we select by hotel type, And we find that most resorts, or actually we don't know because we're not sorting at all, that there are about 4,000 bookings with kids in resorts. Cool. The case for, let's essentially do that same thing for a city hotel. And as we can see here, there's about 2,100 little one bookings. So, yeah. Now I want you to ask yourself, what's happening in this chunk? Because I've been reading them to you. So I'll give you 30 seconds if you don't want to pause to think about what's happening. See if you can read through this. Because in theory, the code is clear enough to tell you what is happening. All right. So what is happening here is we're making a new variable called prop. And we are seeing what the proportion of our sample size here is based on the sum of the entire sample size. So we're seeing what the proportion is. And as we can see here, there's only one resort hotel scenario where they had 10 children. In the city hotel, there were 2 scenarios with like a lot, and then there's a couple of cases of missing data in the city hotels. But the nice thing about this code is it's self-documenting. Okay, so let's summarize. If we want summary stats, we can literally tell it that. So here we have mean of the average daily rate, and we just made that a variable in the summarize function and assigned it to mean, the mean. Ta-da! So summarize changes the data frame entirely. It collapses essentially all the rows down to a single summary statistic and removes all columns that are irrelevant to the calculation. So it does some major reshaping in a way that the group by and kind of that count thing don't. So it's useful for trimming down, but if you don't want that, then you're going to want to use mutate to get those summary statistics yourself. All right, so pro tip. So summarize does let you get away with being pretty sloppy, but it's not recommended. So you can just not name your summary variable and it'll give it back to you. It'll essentially be whatever the function is. I don't recommend that because it's hard because it's got quotes around it and don't do that. But it will let you do it because yeah. So we can do other things. To illustrate here, we can group by and then summarize, and that will give us the same thing as count. Count is essentially a shorthand for group by, summarize, without cutting out all the extra info. Archie, stop it. All right. We can also do multiple summary statistics, which is pretty cool. We can do the minimum, the mean, median, max, all within the same data set, and it'll give us all of those at once. Now, when it collapses everything, it does get rid of everything else, so just be mindful that that is happening. So your turn. So finish up that activity with hotels and do exercises 7 and 8. So I'll see you later. Bye.